Hello, I'm a coordinator from the Programming Club of IIT Madras. This video will be an editorial for contest number 897 Division 2. So, I'll be giving the editorial for problems A and B. So, let's get started. So, this is problem A. In problem A, let's see what they say. Green gold dog has an array A of length n, and he wants to find a permutation B of length n such that the number of distinct numbers in the element-wise difference between arrays A and permutation B is maximized. A permutation of length n is an array consisting of n distinct integers from 1 to n in any order. For example, 2, 3, 1, 5, 4 is a permutation, but 1 to 2 is not a permutation. The element-wise difference between two arrays A and B of length n is an array C of length n where Ci is equal to Ai minus Bi. So there is an interesting method to do this. I'll explain you the method. So let's say that the first line is array A, and now we have to find B such that all elements of C are different. Now what we can do is, for the smallest element of A, we will put the biggest element of B, and then so on. For the second smallest element of A, we will put the second largest element of B, and so on. By this method, all the elements of C are distinct because all the elements of C are in increasing order. Because every element of C is equal to the corresponding A element minus the corresponding B element. So what we have is, when A is increasing and B is decreasing, we have that C is also increasing. And if an array is strictly increasing, that means that all the elements are distinct. So this is the basic method. This is a hint. So now let's move on to problem B. So this is problem B. XOR palindromes. You are given a binary string of length n, a string that consists of only 0 and 1. A number x is good if there exists a binary string L of length n containing x1s, such that if each symbol Si is replaced by Si XOR Li, then the string S becomes a palindrome. You need to output a binary string T of length n plus 1, where Ti is equal to 1 if I is good and 0 otherwise. So let us think, what is the minimum number of ones that we need in L? Let us see. Let us take an example and observe. If we have the first example 1 0 1 0 1 1 1 0 1 0 1 1, so observe that the first and last elements are already the same, so we don't have to do anything. And observe that second last and second elements are different, so it means that we have to change one of them, exactly one of them, so that it can become a palindrome. And similar is for the third and third last elements. Now what does XOR exactly do? Observe that 1 XOR 0 is equal to 1. 0 XOR 0 is equal to 0. 1 XOR 1 is equal to 1. And 0 XOR 1 is equal to 0. Is equal to 1, sorry. So, I made a mistake. This is 0. So basically, if you XOR any bit with 0, it stays the same. If you XOR any bit with 1, it becomes the other bit. So first, we want to find the minimum number of ones in the second array. So we don't need any ones for these two, but for these two we need ones, because these two are a pair. In the third element and the third last element, at least one has to change. and not just at least, exactly 1. And in the second and second last, exactly 1 also has to change. So if you put 1 1 here, and these two are 0. So observe that the minimum is 2. Min is 2. Now, what is the max? Max is such that this is 1 and this is 1. So max is 4. So if you observe what is actually happening, minimum is n minus a number a. Let's say y. No. Let's say this is just y, and this is n minus y. And y is the number of pairs which are not same. Now, for any number x between min and max, does it work? That is the question. Let us see that. If I have number 3, would it work? The answer is no, because if you put 0 here, then the corresponding result would not be a palindrome. So when there are even number of elements in the array, then only 2 and 4 are working here. So we can say that any x is good if it is of the same parity of min. And this is when n is even. When n is odd, there's a slightly different thing. Let us check it out. Let us take this 5 element array. Now this must be 1. Then we can put this 0, and this is, let us say, x, because it can be anything. And both these have to be the same. So they can either both be 0 or they can both be 1. Here min is 1 and max is 4. Is anything possible with 2? Yes. If I just put this 1 and I put these two 0, it's also possible. Is anything possible with 3? Yes, that's also possible. If I put this 1 and then I have to put this 1 and then let's say this is 0. 3 is also possible. 4 is 4 possible? 4 is obviously possible. So for odd numbers, every x between min and max works, and for even numbers, every number which has the same parity as min between min and max will work. So that is the hint for problem B. You can try to implement it. And
hello everyone, I am Aditya Jain, one of the coordinator of Programming Club IITM, and I am here to explain you problems C, E1 and E2 of Codeforces round 897 div. So let's begin with the C problem. In the C problem, we have an array of n integers. Okay, and Alice and Bob are playing a game. What is the game? In Alice's turn, what Alice will do, Alice can add any element x to this array. In Bob's turn, Bob can remove any element y from this array with a condition that y has to be strictly less than x. Now, what Alice wants to do is, the purpose of Alice, the goal of Alice is to maximize the max of this array. To maximize it. And the purpose of Bob is to minimize the max of this array. Now, okay, so what is max? Max is basically the smallest non-negative integer which is not present in this array. For example, if you have an array of 1, 2, 3, 5, what is the max of this array? the max of this array is 0. This is because 0 is the smallest non-negative integer which is not present in this array. So its max will be 0. If you have an array like 0, 1, 2, 3, 4, yeah. So what is the max of this array? The max of this array is going to be 5, because all the non-negative integers which are less than 5 are present in this array, but 5 is not present in this array. So 5 is the smallest non-negative integer which is not present in this array. So its max is going to be 5. Now, let's move on to the question. We have an array, suppose we have an array this 0, 1, 2, 4, 0, 1, 2, 5, 7 and 8. Yeah. So what is the max of this array? Its max is 3, because 3 is the smallest non-negative integer which is not present in this array, as 0, 1 and 2 are present in this array. So 3 is the max of this array. Now, what is the purpose of Alice? The purpose of Alice is to maximize the max of this array. So suppose Alice has to add a number in this array, right? So what if Alice adds 4 in this array? If Alice adds 4 in this array, the new array becomes 0, 1, 2, 4, 5, 7 and 8. If Alice adds 4 in this array, the new array becomes this. Its max is still 3. Max didn't increase. But the purpose of Alice was to maximize the max, was to increase the max. So, if Alice inserts any number which is greater than 3, then the max will remain 3 only, because 3 will still not be present in this array. So, in order to maximize the max of this array, what Alice will do? Alice will insert 3 into this array. So, after inserting 3, the array becomes this. Now, what is the max of this array? The max of this array is 4. This is because 4 is not present in this array and 0, 1, 2, 3 are present in this array. So, in Alice turn, max increased from 3 to 4, right? Now, what Alice inserted? Alice inserted 3 into this array, right? So, now it's Bob's turn. So, what Bob can do? Bob can remove any number from this array, with the condition that that particular number which Bob removes should be less than 3. Because in question it's given that whatever the number Bob removes, it's strictly less than the number removed by Alice. It's written here, the number y must be strictly smaller than the last number added by Alice. So the last number added by Alice was 3. So now Bob can remove any number which is less than 3. Now, suppose Bob removes 2. If Bob removes 2, the array becomes 0, 1, 3, 5, 7 and 8. Clearly, its max decreased. Its max is now 2, because 2 is the smallest non-negative integer which is not present in this array. Thus, the max of the array decreased from 4 to 2. It decreased from 4 to 2. Now, it's Alice's turn again, right? The purpose of Alice is to maximize the max. Now the max is 2. Suppose Alice inserts any number which is greater than 2. Suppose she inserts 6. If she inserts 6, then the array will become like 0, 1, 3, 5, 6, 7, 8. Still, its max is going to remain same. Its max will remain 2, and the max won't increase. What Alice wants is to maximize the max of this array. So what Alice will do? She will insert 2 in this array. So if Alice inserts 2, what is the max of this array now? Its max is again 4. So the max increased from 2 to 4. Do you understand? Like, whatever Bob is removing, Alice will add the same number in order to increase the max. So this was mostly about the C problem. What we have to do is, for initial array, suppose we have an array A1, A2, A3 up to AN. What we'll do, we'll find the max of this array. Now, since we want to increase the max, so what Alice will do in the first step, Alice will add the max to this array. Whatever was the max of this array, Alice will add that max to this array so that the max increases. Now, since Bob can remove only those numbers which are less than max, so it will remove a smaller number. For example, the max was 3 initially of this array, so Alice added 3 into this array, and now the max became 4 for this array. Now what Bob can remove any number which is less than 3. So if Bob removes 2, Alice will again insert 2, so that the max remains 4, max doesn't decrease. So let's consider one more example. If we have this array, for example, 0, 1, 2, 4 and 5. Maybe we can consider we have this array, suppose, fine, we have this array. Now its max is 2, so Alice will insert 2, because what Alice wants is to increase the max, and if Alice inserts any number which is greater than 2, max won't increase. So what Alice will do, Alice is going to insert 2 in it. So my array is now going to become 0, 1, 2, 4, 5. What is its max? Its max is 2. Sorry, its max is 3. Its max is 3. Its max was 2, fine. So the max of this array was 2. So Alice inserted 2 to make its max 3. Now it's Bob's turn. So Bob can remove any number which is less than 2, right? So suppose Bob removes 1. If Bob removes 1, then the array will become 0, 2, 4, 5. Now what is its max? Its max is 1, right? Its max is 1, because 1 is the smallest non-negative integer which is not present in this array. So to increase the max, what Alice will do? Alice will again insert 1 into this array. So its max again became 3. Now, what Alice did, Alice inserted 3, right? If Bob removes 0 now, then the array will become 1, 2, 4, 5, and its max is 0, because 0 is the smallest non-negative integer which is not present in this array. So in order to maximize the max, in order to increase the max, Alice will again insert 0. So the array will now become this 1, 2, 4, 5, and its max remains the same, that is 3. Its max increased. So this was all about the C problem. In short, what we have to do is, first we have an array of n integers. What we'll do, we will find the max of this array, and Alice will insert the max into this array in the first operation. Now Bob will remove a number which is less than max. So whatever number Bob removes from the array, that is going to become the new max. So in order to increase the max, Alice has to insert the same element again into this array. So suppose Alice first inserted max. Now suppose Bob removed A2. So now the smallest element which is not present in this array is A2. So max will become, A2 will become the max. So Alice will again insert A2. Bob removed it, Alice again inserted it into the array. Now since Alice inserted A2, now Bob can remove any number which is less than A2. So suppose Bob removed A1. Now the max will become A1. So Alice will again insert A1 to make it to maximize the max. So finally a condition will achieve, like if we had an array this 1, 2 and 4, 5. First Alice will insert 3. Then Bob will remove any number which is less than 3. Suppose it removes 1. Alice will again insert 1. Now Bob has to remove a number which is less than 1. So suppose Bob removes 0. Then Alice will again add 0 to maximize the max. So what will happen is, after a certain time, when Alice will insert 0, since there is no smaller element than 0, so Bob cannot make any operation and the game will end. This was all about the C problem. Let's move on to the problem E1. E1 is again an interactive problem, but this time the problems E1 and E2 were were comparatively easy than the normal E problems of Div 2. So let's discuss the problem E1. So let's discuss the problem E1 now. Basically there are two versions of the problem E. One is hard version and one is simple version. The only difference between the problem E1 and E2 is, in simple version you can ask at most 100 queries, you can make no more than 100 queries. So you can ask at most 100 queries, and in the problem E2 you can ask at most 57 queries. This is the only difference between the problems E1 and E2. Now, what you have to do in this problem is, you have an array of n integers which you don't know. What you have to output, finally you have to output the XOR of all the elements in it. How we are going to do it? Let's discuss that. So, in the first part of this problem, that is even, you can ask at most 100 queries. 100 queries you can ask. So, what are queries? What is the type, like what you are going to ask in a query? So, in a particular query, you will enter the number I. Okay, and what you will get as response of this query, you will get the XOR of k elements starting from it, like ai XOR ai plus 1 XOR XOR ai plus k minus 1. So, in a particular query, what you do, you give a number I, and in return, you get the XOR of the k elements starting from I. So in a particular query, you will enter a number I. In response, you will get the XOR of ai plus 1 up to ai plus k minus 1. This is the query. In response, you get this thing. Clearly, I should be less than n minus k plus 1. This is because it should be less than equal to n minus k plus 1. This is because if I is greater than n minus k plus 1, then you can't have k elements after it. You should have k elements after it. That's why I has to be less than n minus k plus 1. So, let me summarize the question. And you have at most 100 queries. In a particular query, you will enter the number I. You will get the XOR of, in response, you will get the XOR of the next k elements, that is ai XOR ai plus 1 plus like XOR of ai plus k minus 1 till ai plus k minus 1. And what you do after this is, suppose the initial array was a1, a2, a3, ai plus 1, ai plus k minus 1 and an. So after a particular query, what will happen? After a particular query, like suppose in a particular query you entered the number I. So first thing is, you will get the XOR of the k elements starting from the ith element. Also, after that, these elements will get reversed. So the new array will be a1, a2, a3 up to ai minus 1. Then after that, since this part gets reversed, so my array will become, after this it will come ai plus k minus 1, ai plus k minus 2 up to ai, and then it will again go up to an. So in short, basically, in a particular query I, you will get the XOR of ai XOR ai plus 1 up to XOR of ai plus k minus 1, and then these elements will get reversed in the original array. For example, if the initial array was a1, a2, ai minus 1, ai plus 1, ai plus k minus 2, ai plus k minus 1 and up to an. After ith query, after the query, when you entered the number I, you got this in response, and the array will become a1, a2 up to ai minus 1. This part gets reversed, so it will become ai plus k minus 2, sorry, ai plus k minus 1. It will become ai plus k minus 1, ai plus k minus 2 up to ai plus 1 comma ai, and then this part will be as it is, so it will remain as it is, like it will become an. So I hope you understood the question. Now let us make two cases for this problem. Case 1, if n is a multiple of k, that means that k divides n, so n modulo k is equal to 0. So in this case, what you will do is, suppose like n is equal to, for example, 3k. So these were k elements, these were k elements, and these were k elements. N is equal to 3k. Now what you will do is, you will find the XOR of these k elements first, then you will find the XOR of these k elements first, then you will find the XOR of these k elements, And then suppose you got a number x from here, y from here is output, z from here is output, then what your answer will be? Your answer is going to be x XOR y XOR z. So if n is a multiple of k, you'll find the XOR of k of all the segments, like of segments of length k. You'll first find the XOR of first k elements of this array. It will be, suppose it is x. Then you'll find the XOR of next k elements, it is going to be y. You'll find the XOR of next k elements, it is going to be z. You'll keep on finding the XOR of these segments, and then you'll take the final XOR. So x or y or z, if you see, it includes the XOR of all the elements of this array. Now let's consider the case when n is not a multiple of k, that is case 2. n% k is not equal to 0 this time. So what are you going to do in this case? Suppose n is equal to 3k plus 1. Okay, so these were k elements, these were k elements, these were k elements, but now we have one element left. Sorry, basically if you see, it's in the question, it's written that both n and k are even integers. It's written here, yeah, even integers n and k. So n modulo k can never be an odd number. So n modulo k, since it can never be an odd number, so the remainder has to be even. Now let us assume the case when n% k is equal to 2, that is, we have two remainders left. Now what you will do is, first you found the XOR of first k elements of this array, then you find the XOR of second k elements of this array, then you find the XOR of next k elements of this array. But now you can't find the XOR of these elements. Why? This is because here I is equal to 3k plus 1, and I has to be less than equal to n minus k plus 1. That is, in this case, it will be less than equal to 2k plus 3. So you can't find the XOR of these two elements now. So how you will find the XOR of these two elements? So let's discuss it. Suppose you have the XOR of x, you have the XOR of these k segments, like you have the XOR of this segment of length k as x, you have the XOR of this segment of length y, of length k as y, you have the XOR of this segment as z. Now we had one segment of length k, another segment of length k, third segment of length k, and two numbers left. We have the XOR of this, we have the XOR of this, we have the XOR of this as x, y, z. So I have the XOR of all these elements. I have the XOR of all these elements, which is equal to x XOR y XOR z. Now what I want to find the XOR of all the elements of this array, but these two elements are left. So how to find the XOR of these two elements? How to find the XOR of these two elements? Let's discuss that. So okay, so I have the XOR of first 3k elements, right? Now I need to find the XOR of these two elements, right? These are the elements remainder. The number of elements is equal to the remainder that we get on dividing n by k. So now let's consider, like, we had let me summarize it. We have three segments of length k and then two numbers. We have the XOR of these 3k elements as x XOR y XOR z, which we calculated initially, and now these two numbers are left. Okay, I have to calculate the XOR of these numbers, so that, suppose the XOR of these numbers is w. So I'll combine these, I'll take the XOR of all these four numbers to get the XOR of entire array, right? So how to find this w? Let's discuss that. So now consider k minus 1 elements of this segment and 1 element of this array. So suppose the k minus 1 elements are, like, you will consider the last k minus 1 elements of this last segment. Okay, so suppose, like, you will start from the back, you will take k minus 1 elements of this segment. So suppose the k minus 1 elements are b1, b2, b3, minus 2, bk minus 1. Now you have two arrays, two numbers, right? Okay. You have two numbers. You want to find the XOR of these two numbers, right? This is our goal, to find the XOR of these two numbers. How you will do that? First of all, what we will do is, we'll find the XOR of these numbers. So, suppose these numbers are A and B. What our purpose is? Our purpose is to calculate A XOR B. This is what we want. Now, what we'll do, we'll calculate the XOR of these two numbers, like the segment of length k. Clearly there are k minus 1 elements now here, and we added one more element. Now, we took the k minus 1 elements from the last segment, k minus 1. Then we had A here and we had B here. Now what I am telling is, what we'll do, we'll calculate the XOR of these k elements. And suppose it's equal to some random number, say it's equal to m. So m is equal to b1 XOR b2 XOR up to bk minus 1 XOR a. Suppose this is equal to m. Now, after calculating the XOR of these numbers, what I will have, this array will get reversed, right? This segment will get reversed. So after performing this query, what will be the new segment? The new segment is going to be A, bk minus 1, bk minus 2 up to b1, and we have b here. Now what I'll do, I'll calculate the XOR of these elements, these k elements. So let's the XOR be equal to n. So n is equal to k bk minus 1 XOR bk minus 2 up to XOR b1 XOR b. Now clearly see m and n. If you see m and n, m is the XOR of b1 to bk minus 1 XOR a, n is the XOR of b1 to bk minus 1 XOR b. So if you see clearly, m XOR n is equal to a XOR b. What we wanted? Our purpose was to calculate a XOR b, and we actually calculated a XOR b. Now, we had the XOR of these 3k elements. We found the XOR of these two elements. We'll take their combined XOR to get the XOR of the entire array. So this was the main logic behind the problem even. Now let me brief you again. So what we'll do is, if n is a multiple of k, you will take k segments, you will take like k elements, then the next k elements, then the next k elements. You will find their XOR. You will take the next k elements, right? You got the XOR for each of these segments. Then you will combine their XOR to get the XOR of the entire array. If n% k is not equal to 0, what are you going to do in that case? So in that case, what you will do is, first you will find the XOR of k elements. You will keep on finding the XOR of k elements. Now a condition will come when there are no more k elements left. So suppose there are x elements left. Clearly x has to be even, because n and k both are even. So now you want to find the XOR of all the x elements. So what you will do is, suppose this was the last segment, you will consider the k minus 1 elements of this segment. So you consider the k minus 1 element of this segment, and you have x elements over here. I have the XOR of all the elements, there are x elements left now. So I have the XOR of all the elements before that. Now my goal is to find the XOR of these x elements. So my goal is to find the XOR of these x elements. Right? Now, how to find the XOR of these x elements? I considered the k minus 1 elements of this segment that was just before it. Now I will take one element of this, one element out of these x elements, and I will take calculated XOR. Suppose it comes equal to A1, C1 suppose. Now what will happen, these after every query the segment that you choose gets reversed. So what will happen, this element will come here, these k minus 1 elements will now come here, and here the remaining are x minus 1 elements. What is C1? C1 is the XOR of this k minus 1 elements and this element. Let's call it B1. So what is C1? C1 is the XOR of k minus 1 elements XOR B1. This is C1, right? Now what I'll do, in the next query I'll calculate the XOR of these k elements. These k minus 1 elements are the same as last time, and this element which is B2. So suppose their XOR is C2. So what is C2? C2 is the XOR of k minus 1 elements XOR B2. Now after this query what will happen, again k minus 1 elements and B2. This segment gets reversed. So these two are going to swap. So it will become B1, B2. Here are the k minus 1 elements, and here x minus 2 elements will remain. So we'll keep on taking the XOR of this k minus 1 segment with these elements. Now what you'll get, like suppose x was 2, so you have one C1, you have C2. Now if you take the XOR of C1 and C2, since k minus 1 is getting repeated in both of them, so the effect of k minus 1 is eventually going to vanish, and C1 XOR C2 will be equal to B1 XOR B2. Now if you calculate the XOR of all the elements like C1, C2 up to Cx, calculate the XOR of C1, C2 up to Cx, you will get it equal to B1 XOR B2 XOR Bx. Why this is happening? This is happening because x is an even number. X is an even number because n and k both are even, so n modulo k has to be even. So since x is an even number, now what was C1? C1 is basically the XOR of k minus 1 elements and the XOR of B1. C2 is the XOR of k minus 1 elements and the XOR of B2. So if you clearly observe in C1, C2, Cx, in all of these terms k minus 1 is getting repeated, and since x is even, so k minus 1 is repeated in their XOR. K minus 1 is those k minus 1 terms are getting repeated in even number of times. Therefore their XOR will eventually become 0, and what will be left with? Will be left with B1 of B1 of C1, B2 of C2, and so on. So this is all about the problem even. Now you must be wondering why, how we can be sure that it's less than 100 queries. So what you are doing is, first you will find the XOR of all the k segments till you can find. So this thing can, how many queries will you need for it? You will need n by k queries for it. This is because suppose n was 5k plus 2. N was 5k plus 2 for example. So how many queries will you need for calculating the XOR of k elements? Clearly if you observe, there will be 5 such segments of length k, right? So you will need only 5 queries, that is you will need n by k queries for it. Plus, now what is the remainder? Remainder is 2. So if you clearly observe what I did, I took the k minus 1 elements and the element that is just next to it. Then I will take the k minus 1 elements and the element which is next to it. So how many queries I will need? I will need n% k queries. So these are the total number of queries that I will need for this question. Now if you see the constraints, n can be maximum what? N can be maximum n is less than equal to 2500. So n can be maximum, n can be 2500. K square is less than equal to 2500 and it's greater than equal to n. So clearly k's minimum value will be root n, because k square is greater than equal to n, so k's minimum value will be root n. Now if you observe the number of queries, it will be n by k plus n percent k. So it will be root n plus n percent k. These are the total number of queries. Now, what can be the maximum value of k? The maximum value of k is basically 50, right? Because k square is less than equal to 2500. So the maximum value of k is 50. So if k's maximum value is 50, n percent k's maximum value can be 49. Because the maximum remainder that you can get after dividing n by k can be 49, because k is 50. The maximum value of k is 50. So 49. This term is the maximum value of n percent k is 49, and the maximum value of root n is 50. This is because n is less than equal to 2500, so root n is 50. So the total number of queries are less than equal to 99, and we can make 100 queries, so it's less than 100. This is about the problem even. Now let's move on to problem E2. The only difference between the hard version and easy version is now you can make at most 57 queries. So again we'll make two cases. Case 1 is if n percent k, that is n is divisible by k. Then again we'll take the first k element, then the next k element, and so on. We'll calculate the XOR of each of these k elements. Suppose it comes x1, x2, x3, and so on. Then their XOR will give me the final answer, that is the XOR of the entire array. Clearly, there can be, if n is divisible by k, so the number of segments will be n by k. So I'll be done in n by k operations, which is less than equal to 50. Yeah. So I'll be done in 50 operations if n percent k is equal to 0. Now, let's discuss the case 2 when n percent k is not equal to 0. So that means you will make a segment of length k, you will make a segment of length k, you will make a segment of length k, then you have some terms left, like you have some numbers left. So clearly the number of numbers left will be less than k, that is n percent k. You made a segment of length k, then length k, length k. So clearly this thing will be equal to, the number of segments will be equal to n by k. Now the number of terms of the array left will be equal to n percent k. Now since n and k both are n and k both are even, so n percent k has to be even. So there are even number of terms left now. Now let us consider this last segment. There are b1, b2 up to bk elements of the last segment. Then there are suppose let's say x is equal to n percent k. So then there are x elements. So these are x elements and these are k elements. Now, same as last time, we have the XOR of these elements. What our goal is to calculate the XOR of these x elements. Clearly x is even. Now what you will do is, from these k elements, you will take k minus x by 2 elements. Okay. So from this segment, this was the last segment, you took k minus x by 2 elements from the last segment, took x by 2 elements from the remaining x elements. Now you will calculate the XOR of these two. So the XOR will be equal to XOR of k minus x by 2 elements plus XOR of these x by 2 terms. This is equal to, say, w. Now, after doing this operation, since the array gets reversed, therefore these x by 2 terms will come here and these k minus x by 2 terms will go here. So now what we'll have is, here are the x by 2 elements, here are k minus x by 2 elements, and here are again x by 2 elements. Now what I'll do is, I'll calculate the XOR of these k elements and let the XOR be y. So y is equal to XOR of k minus x by 2 elements and XOR of x by 2 elements. Now XOR of the remaining x by 2 elements, let it call x dash. Yeah. Now if you take w XOR y, since k minus x by 2 elements get repeated in both these, that is, you took k minus x by 2 elements from this segment, right? So this segment gets repeated in calculating XOR for both w and for y. So if you take w XOR y, the XOR of these k minus x by 2 elements vanish, and what we are left with is the initial x by 2 elements of this array and the XOR of final x by 2 elements of this array. So w XOR y gives us the XOR of all the remainder terms, the x terms, XOR of x terms. So what we'll do is, let me summarize this part. First we'll find the XOR of all the k element segments. Then we'll be left with some terms here. Okay, so suppose the number of terms left are x is equal to n percent k. What I'll do is, I'll take x by 2 terms from the remaining x terms and k minus x by 2 terms from here. So I took the first x by 2 terms from the remaining x terms. This is x for xf. Xf represents the first x by 2 terms. I'll take the first x by 2 terms from this and k minus x by 2 terms from this, and I'll calculate their XOR. Let it call w. Then what I'll do, I'll take the last x by 2 terms of the remaining x terms and k minus x by 2 terms of this last segment, and that will give me the XOR of like the first x by 2, this was x last by 2, that is the last x by 2 terms, XOR k minus x by 2 terms that we took from the segment. Now if you take w XOR y, what I'll get, these two are going to cancel out because they are repeated even number of times. So I'll get the XOR of x, that is first x by 2 terms plus last x by 2 terms, XOR of first x by 2 plus last x by 2 terms. So clearly the number of operations will be like, for this part we are finding the XOR of these k segments. It will require n by k operations, and now I'm just like breaking the remaining terms into two segments, x by 2 and x by 2, and calculating their XOR. So it will be n by k plus 2 operations, which is less than equal to 52. So it's n by k plus 2 operations, which is less than equal to 52. Thus will be done in 52 operations. This is all about the problem. Thank you.